Okay, morning. First thing we're going to do before we dive into chapter 8 is review for some, introduce for others. Okay? I have heard from a great many of you since I introduced this topic in the last semester about square roots, and most of you that addressed me were unfamiliar with it or don't remember it or are uncomfortable with it. So I want to go over some things for you and provide some reference material for you. Okay, so before we start chapter 8, which deals with right triangles, we're going to deal with a lot of square root problems from now on. Okay, so first things first. I have put into the chapter 8 folder notes for simplifying radicals. Okay, it's a lot of steps, a lot of things. Refer to it when you need it. Okay? There's also a list on there of the numbers and their squares from 1 to 15. While I don't say memorize them, if you do or are very familiar with them, you will begin to recognize them within or as factors of other numbers, which will make life much easier for you. Trust me. Okay? Also, we have several worksheets there. Okay? We'll get into those. Some of them have the answers attached to them, so you can do a few problems and check your work. Okay? The difference between rational and irrational numbers. We review that real quick. Rational. The number 5 is rational. Okay? Pi is irrational. Irrational is a non-repeating decimal number. So, when we talk about exact and approximate, okay, we have to think about where we are and what we're talking about. If we are talking about how far is it from here to Santa Monica? Okay, an approximate distance, that's 20 miles. Okay, that's fine. Okay, if you're talking about, well, how much material do we need to span this gorge to build a bridge? That's the time for exact. Okay? When we talk about math in geometry class, exact and approximate have a couple of different concepts. The square root of 3 in that form, radical 3, is an exact answer. If we hit the square root key on our calculators, you're going to get 1.732 ... and forever. It's an irrational number. So that is considered approximate. Time and a place. Okay? Here's the one thing you do need to pay attention to. The answer needs to be formatted according to the directions. If I tell you, leave in radical form, simplified radical form, it's got to be this way. Okay? If the question says round to the nearest, anytime you see round, you know it's going to be approximate. Okay? Usually it's round to the nearest hundredths or tenths, something like that. And that's when you dig out the calculator and get to work. Okay? We have some rules. Okay? The rules you have to be familiar with. Okay? Rules for radicals. Okay? Radical is the square root sign. That's all it is. Okay? Never, ever leave a perfect square inside a radical. Can't do it. It's got to come out. Never leave a radical in the denominator. Show you how to move that in a bit. Never leave a fraction in a radical. Okay? Never, ever feed a Mogwai after midnight. If you're not sure about this, ask your parents or Google it. It's fascinating. Okay? Next, how to rationalize. Rationalize is how we get rid of fractions and such. So, if I look at this, okay, these are two fractions. Okay? In one, I've got the radical underneath, and it can look this way. It can be 3/7 under one radical. Means the same thing. You can split them, keep them together. It's usually easier to split them if you're going to rationalize it. Here's what we do. The process is very, very similar to what you did in elementary school when you were adding and subtracting fractions. Because you have to have a common denominator, you multiply the top and the bottom of the fraction by 1. 1 can be represented by any number over itself. So that's what we're going to do here. The number 1 we are going to multiply is the denominator, the part that's in the radical, over itself. So, remember, when we multiply by 1, we are not changing the value. We are changing the appearance. Okay, we've dealt with that before when we talked about substitution. No change in value, change in appearance. Okay? So, when we deal with that, we're going to say, okay, 3 times 7, that stays inside. Okay? Now watch. Here's why we do this. Radical 7 times radical 7, and the square root of 49 is 7. So that's why we do this. Anytime we multiply something by itself, we are squaring it. When you square a square root, the result is the number itself. Doesn't matter what you... Radical 5 times radical 5 is the square root of 25, which is 5. That's why we multiply by the denominator over itself. Okay? Here, 2 ways to do it. Number 1, we can just multiply top and bottom by the square root of 12. 2, we can simplify this first. Both ways will get us the same answer. It's okay. Okay? So, your choice on that, however you're most comfortable. Okay? I'm going to turn this, I'm going to simplify it first. Okay? 4 times 3. Okay, the 4 is a square, comes out. Okay, so now I'm going to multiply by the square root of 3. Okay? This, we have to remember, is a multiplication problem. It is read 2 times the square root of 3. Okay? And that's going to stay without our problem. Okay? So when we multiply radical 3 by radical 3, we know we get the square, so we get radical 9. Okay? Square root of 9 is 3. 2 times 3 is 6. Can we simplify? No, we're done there. Okay? So that's what we do. So now I've got several examples or samples to go through. And you'll notice I did something semi-intelligent today. I set the problems below where that bright light is. Okay? You'll notice it only took me a semester and a couple of months to figure that out. I'm not stupid, but I'm not as bright as that. Let's go with that. Okay? When we take a square root, okay, we are taking the square root of a number that's inside the square root sign. Okay? Pretty straightforward. A square root is a number that multiplied by itself. So when we're looking at factors, for example, if I look at the number 16, 4 times 4, which is the square root. But 16 can also break into 2 times 8. Okay? 2 and 8 are not the same number, so those are not square roots of 16. They are factors of 16. When we're looking for the square root, we are always trying to find the largest number factor that will go in as we break it down. Now this is a very simple one, okay? Because 225 is the square of 15. 15 is the square root That's it, you're done, the sign no longer comes up. I see a lot of people leave that under the radical. This is no different than a plus or a minus sign. Once you add two numbers together, you get rid of the plus sign. Same thing. If we have a perfect square, that sign's gone. It's done its job. Okay? So we move on. Okay. Let's look at 50. Okay. A lot of factors of 50. Okay? 1 times 50, 2 times 25, 5 times 10. Okay? What I do is, when I think through those in my head, okay, yes, I've done this for 100 years, so it's easier for me. But what I want you to understand is, okay, if you're not sure, it's an even number here. Divide by 2. Okay? See where that takes you. In this case, it's the key to finding this. Watch. The square root of 50 can be written as 25 times 2. 25 is a perfect square. The square root of 25, sometimes people see this differently. The square root of 25 is 5. It is allowed to come out of the radical. Radical 2 stays in. It's not a square. So 5 radical 2 is the simplified version of radical 50. Okay? Okay, next. 288. I see this very easily, once again, because I've done it for so long. Okay, the numbers are familiar to me. But if you are familiar with your squares, like I said a second ago, okay, and you think about it, wait a minute. 12 squared is 144. Wait a minute, 144. Wait, that's 2 times 144. That's the shortcut. Can you break this down into its roots? Yes, you can. Is it the most efficient way to do it? No, it's not. Okay? In fact, I see more people make mistakes doing it that way because they forget a 2, they forget a 3 for their final answer. And it's an incorrect answer at that point. Okay? The more efficient you can be in solving a problem, the better. Watch. Square root of 144 is 12. And that's your simplified answer. Okay? Next, I've got 3 times the square root of 8. The number outside is just going to come along for the ride right now. It's not going to multiply anything until we get numbers out of the radical, and that'll happen. So this stays 3 times. 8 can be broken into 4 times 2. Okay? The square root of 4 is 2. Okay? And that's basically it. Once the number comes out, then we can multiply. So 6 radical 2 is the simplified version of 3 radical 8. Same value, different appearance. Okay? 7 times the square root of 63. Okay. 7 stays out. Okay. Square root of 9 is 3. And there's our answer. Okay. I want you to notice something here. The first rule I gave you over there was no squares are left inside. Okay? 2, can't break it down anymore. 2, 2, 7. It's not always going to be prime number. Okay, sometimes it'll be like the number, well, let's see, 15 has no squares in it. 15 has factors, but no squares. Okay, that's life in the big city. Okay, well, that's what we work with. Let's go over here. Okay, got 4 more to deal with. These deal with the division aspect. Okay. Let's see, got it. There we go. Okay. So, square root of 3/4. Okay? Probably, okay, and this is just my comfort zone, I think it's easier to break this up right now, and here's why. Okay? Means the same thing, it's just written in a different way. The reason I did this is because I know 4 is a perfect square. And once I get to this point, the square root of 4 is 2. That, well, we can clean up the 2 a little bit. Okay, that's our final answer. We leave it there, that's fine. Okay? 1/5. Can we simplify that? No way to divide it, okay? So we'll just say, okay, we'll do it this way. Okay? I'm going to separate it and watch what happens. Okay? Square root of 1 is just 1. Okay, we don't really have to do anything with that. But if you remember back to the first board over there, to rationalize this, because there's a radical in the denominator and that cannot exist, we have to rationalize this. Okay? And that's going to give us our answer. We know that radical 5 times radical 5 is radical 25. Radical 25 is simply 5. That is your final simplification. Okay? Okay, here. Okay? In this one, we've already got it separated. So we're going to stay with that. Okay? So what we have done is we have taken the radical in the denominator, make 1 out of it, so to speak, and we go from there. Now, I want you to look at this. Radical 10 cannot be simplified. There are no squares in it as factors. 1 times 10, 2 times 5, no factors. Excuse me, no squares as factors. The 2 is actually the number 2, not a square root, so we cannot divide to simplify. That's it. That's your final answer right there. That's all we can do with it. And we leave it that way. Okay? Our last one. We have a fraction outside a radical, okay? And we're multiplying. So, here's what we're going to do. This cannot be divided. 3 doesn't go into 28 evenly. So, what we are going to have to do here is break it down. So, okay, I want to simplify this first. Okay, it's going to give me smaller numbers inside. Okay? That's what we have to deal with. That's going to be a 2. Okay? So we're multiplying by 1. I've got 3 Okay. 3 over 4. Radical 4 becomes 2. Radical 7 times radical 3 is radical 21. Radical 3 times radical 3 is just 3. Okay? Radical 3 times radical 3 is 9. Square root of 9 is 3. Here we go. Watch this. Gone. And what we've got left is the square root of 21 over 2. Okay? And that is our little primer for square roots. Okay, once again, this chapter is going to be quite a few of them, and they are going to remain part of what we do for the rest of the semester. Okay? Okay. Take pictures and I'll put them on the files for you. Okay? Ladies and gentlemen, take care. Enjoy your day.